Oh, good morning. I'm trying to stay on schedule with my films on COVID-19 while I continue with my other work in the fields of proxia, staying oxygenated, understanding that oxygen fuels many involuntary self-actualization, evolutionary processes through our wonderful mitochondria that host us. And so that's after this one today. So as I continue with manganese, which is a response to hypoxia in the system and its connection with COVID-19, as we have discussed and reviewed, and should not forget that 2 little dots of manganese. We have a lot of manganese. We need a lot of manganese, does a lot of things. It's involved in origins of life, embryogenesis, biogenesis, but there are 2 little dots of manganese in the, let's do the different color, non-specific proteins that enable the virus. So the virus is like a snowflake. Okay, so for the snowflake to lock on on the ground or something, there's a locking mechanism that enables it to lock and then melt into the ground. Let's take that analogy. So it's surrounded by, I think, what they call N clusters. I forget exactly what they call them. And then there's a C cluster. Oh, gosh. Yeah. C cluster. And then there's another cluster there. I forget exactly. What's another cluster? I forget. Oh well. So, but then there's manganese right in the middle of this that gets the viral DNA comes in with its 3-unit tail, and the that's the end, and the 5-unit leader. And so this manganese goes cook and takes our RNA. This is human RNA, and gets what it needs to then signal the nucleolus to create copies of itself that then go out into our system. And in the process, this is the mitochondria where the leader is made. This is the mitochondria where the double membranes are generated. And this is our nucleolus, where the tail of this viral RNA is found. So together, and the mitochondria are usually hanging out here. When COVID moves in, they all of a sudden get closer and they all work together to make more and more viruses that then get expunged into the system. So it, in many ways, and I say this in all seriousness, that because we need to really look at it, COVID-19 is our new mitochondria. Why? Because we flipped our planet. We eat all the time. We don't breathe much anymore. And it's got a perfect breeding ground to get in and do this. But that's not what I'm going to talk today about. Where there's causation, all you find is evidence. I keep finding the evidence. I don't have to look very far usually to find it. In other words, when you look at the mitochondria during COVID-19, they're nice little bean shaped, and the electrons are coming and going, and the calcium is rolling out. Yes, calcium, because there's oxygen coming in. Oxygen comes in, calcium flows out, we get ATP, ATP. And this is good. Yay, this is good. This is how it's supposed to work. Oxygen in, ATP out, like super ATP. And in this process, there are no antioxidants. There's no damage, there's no cleavage, there's no destruction, there's no harm, there's no hydrogen peroxide, there's none of that, from my understanding. No antioxidants. This is self-actualization. This is the DNA just unpacking. DNA unpacks. Woohoo! We evolve during this process. We evolve, we self-actualize. Because sometimes evolve means cutting things away. We evolve in a dangerous environment. And when we sense danger, the amygdala, cleave, cut, cleave, cut, cleave. All that's left is survival mode. That is one definition of evolve. But we want, pure evolve. I'm going to call it pure evolve. Because it's different, because there's no amygdala. So this is the calcium is rolling. Now let's flip that. All of a sudden we are low in oxygen, we're anxious, we're hypoxic, we're full of fear, that frontal lobe is going, and the calcium, which is inside the mitochondria, stays in there, doesn't go out. But the very same channel puts out manganese, not magnesium, manganese. And what does that manganese do? It cleaves oxygen out of water. So it gets its oxygen through water, just like fish, just like plants, just like algae. And there are antioxidants, many, many antioxidants. When calcium is sequestered inside, manganese is let loose, zinc is let loose, kill, destroy. Copper runs a little rampant because it's not protecting the calcium signal anymore. And we get antioxidants, and we get disease, and we get death. And look at the 2019 Nobel Prize in Physiology. Greg's all, internal, non-environmental type disease. Well, this COVID looks like it's more of an environmental type disease, because let's look at what I found. So I'm saying, okay, manganese. We don't have enough manganese. Why don't we have manganese? Well, we can start with the mitochondria. I'm not sure what manganese has different valences. The one that we like the most and that works for us and is really friendly, and is really friendly for the virus too, just a little bit. It's like salt. For us, it's like mana. Yes, we use manganese, helps us get that oxygen when we have a period of low oxygen or fear, so that we don't, perish. But better to keep it inside the mitochondria for emergencies and give it oxygen. And you feed that mitochondria, it loves to eat oxygen. Yum, 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 yum. Can't live 5 minutes without it. And if we really don't have it, glucose will give us a little bit of energy. But we can live 5 weeks without glucose. I don't think we can live 5 weeks without it now, because we're so chronically dependent on it. We have evolved to be dependent on it. That's a problem. So it eats oxygen, yum, and then it spits out nuclear level ATP, atomic energy. That's what the mitochondria does when we give it oxygen. When we don't give it oxygen, we have antioxidants, disease, death, heart failure, cancer. Cut off oxygen to a cell and you get cancer. You don't need manganese anymore, because cancer is a zero manganese. When they give manganese to, in one of these studies, mangaphotopir, doesn't go to cancer cells. Where does it go? Where does it go? So we're going to talk about where it goes. It goes to our immune system. It goes to the choroid plexus. It goes to the anterior pituitary gland, where hormones and excitation, energy mechanisms. It goes to the lacrimal glands for immune. It goes to the sublingual glands for immune. It goes to the submandibular glands for immune. Doesn't go to the frontal cortex. Doesn't go anywhere else. That seems to be where it goes. All right, let's go back to embryogenesis, right? We were talking yesterday, 0 to 16 weeks, no oxygen, no iron, neither one of those things, anemia, mother's feeling sick, just wants to lay in bed, doesn't want to eat. And what's happening? Zinc and copper, and then they kind of switch out copper and zinc. And in that thing, up to 1 trillion neurons. This is our incubation period, 0 to 16 weeks. And then try 2 to infinity is mitochondria, ATP, iron, manganese, oxygen, fluid, and the other biosubstrates that we know, calcium for cell activation, copper to protect that activation, potassium, of course. So that's us. This is us. So I was looking, okay, so we can live 5 days without, 5 minutes without oxygen, right? That's how we're supposed to live, unless you're got COVID and happy hypoxic, and it's like, new game in town, new mitochondria in town, and it's called COVID-19. So we need to put that on the table and make some mature, adult, patriarch type decisions. What are we going to do with this information? You know, me talking about manganese as a little break here is like when there were rickets back in England. And you'd say, oh, well, a lime or a lemon or a citrus fruit, some sort of citrus can help you with that. And they would look at you like you have 14 heads. They'd never heard of a lime. They'd never seen a lime or lemon or piece of fruit. That's for kings and queens, huh? So manganese, get used to it, because we have COVID-19 ickets. And manganese will knock them off. All right, so hydration. We looked at that yesterday or Friday. 5 days without water, or is it 5 days without manganese? That's the bigger question, right? And that's what I started looking at over the weekend a little bit. And so 5 days without water. And what did we find out on Friday? That the manganese has been stripped from water. It is filtered out. So our water is purified, but it's maybe not as healthy as it should be because the manganese has been removed from drinking water. What does that mean? That means that, you know, if you got a glass of water and take it from groundwater, after a day or two, it turns a little cloudy and it gets a little reddish. And it's not that it's not healthy. It's got manganese in it. So we can't have that, can we? But we barely drink from natural sources anymore that are filled with manganese. And I don't think you can boil the manganese out either. So you can purify water, keep the manganese, drink it, and keep your manganese strong. So then I started looking into, I thought, okay, well, if they get it out of water, people don't really, it's like the lemons and limes. I don't know, I'm going for the snake oil to work with my rickets. Someone told me the snake oil will work. So forget about the lemons and limes, but lo and behold, lemons and limes. Same with this eye condition in Africa where the Johns Hopkins esteemed doctor put a drop of vitamin A in, cured that. So we have to look at these metals because that is origins of life, embryogenesis, biogenesis, evolvogenesis, pure evolve, our purest evolution is with oxygen and with manganese as the backup and the soldiers in the wing. We have so manganese with 2 electrons, and then they have 3 electrons and 4 electrons. I believe they even have 5 electrons. It's a very dynamic metal. It's very flaky and combines with water, obviously, to pry oxygen out of water. Does that a lot. Very well known for that. It also creates, with an extra electron, it creates sediments and materials. It creates stuff. For instance, in the pipes, that's why they cut it out, because it clogs up the pipes. It creates things. And then in other forms, it does other things. But the most ideal form is in our body, which is the manganese 2 that enables our survival and thrival. So what I looked up yesterday was what I found very similar to what's happening in this egg. All right, we don't need to go here. So what I was looking for was farming agricultural enrichments that have they stripped the manganese out of agriculture? Have they? I was looking for that. I'm like, oh gosh, that's no small endeavor to look that literature up. Unfortunately, I didn't have to go far, because what I found was even better than had they stripped manganese. Do they even know what manganese does for plants? Have they stripped it out? In other words, we have natural sources of manganese, almonds, leafy greens, other sources. And, how do they fertilize those? Are they just like our water? We have purified water that has no manganese. Do we have purified plants and food sources that have no manganese? Most people don't know what manganese is or how important it is. We see it in the virus. So the virus is one thing. Let's go back to the virus, because that's what's happening these days. COVID-19, it's got its little RNA inside that the manganese goes pop for the, to pair with this, it pops off our RNA because it's signaled by this virus. Right? So the virus is one thing. It's like snowflake, right? Has no thought, no feeling. It's just a manifestation of, there's all this glycoprotein in the world and these animals. Let's go in and have a party. Let's go in and we found a new home. And it's a killer. We know that. So totally separate. So these are specific proteins. These are specific glycoproteins that make this virus. But we have something called a non-specific protein. They call it 15. And it also creates this UENDO. I forget exactly, but it cuts off, what it does is cuts off the ends of our DNA to pair with this RNA. It cuts off the ends of our RNA to pair with this RNA to create more virus. And what's in this? 2 little dots of manganese, very highly reactive. If manganese can split oxygen out of water, it's also splitting this human RNA strand to pair with the virus. That's what it does. It's like salt in a soup. Little bit of salt, yum, works just fine, makes that soup work just fine. And the virus prefers manganese to do this. It picks up manganese and has this non-specific protein. It's surrounded by other stuff, but manganese is the key that unlocks and cleaves the RNA, just like salt in a soup. Yum. Perfect. So what happens if we put too much salt in a soup? Yuck. And that's why we need manganese as a triage, because you add manganese to this, you put a lot of manganese in the arena, more and more manganese, and this thing does not work. Just like the soup. Too much salt in a soup, too much salt spoils the broth. And that's exactly what increased manganese in our system should and will do to this virus. Destroy it. It doesn't work. Too many keys destroy this cleavage. Pure and simple. All right, so what's more evidence that I found today? Am I keeping you in suspense again? Yes, because what I did find, I was looking for farming. Well, they stripped it out of water. Did they strip it out of our food too? I didn't get there because I found some other research on eggs. And wow, eggs used to break. You look at them and they break. And once you break an egg and you let oxygen in, just like us, you kind of ruin the egg. You've got to deal with it right away or it's gone. Same with gestating chick embryos. Once that egg is cracked and the oxygen gets in, it's over. It's really hard to rescue. Same with embryogenesis. And it'd be curious to follow that, how they get these way premature infants. I'm sure there's correlations and analogy, causal triages that are similar to what we're talking here. Because where there's causation, all you find is evidence. Isn't that awesome? This is great science. Great science. So let's look at the egg yolk. So I found this amazing article that they took young hens and old hens. This is even more exciting because we're looking at the young versus the older hens. And what did they give them? They gave them copper, zinc, and manganese. And some of them they gave no manganese. And some of them they just gave copper. And some of them they just gave zinc. These are Brazilian. And the references, I mean, these farmers, these egg farmers are dependent on manganese to make sure this shell, the shell of the yolk, is going strong. That's where manganese. Remember we talked about in our embryogenesis, the mitochondria hang out in diploid shells. They hang out. They wait patiently, empty, waiting. And you've got this huge, this fat shell, as it were, that keeps the oxygen out, that keeps the iron out. And iron is not a part of this because it only becomes a part when it starts carrying oxygen to the manganese fleshed mitochondria. So what? And I was like, where's the manganese during this time? Is it in these empty shells of these mitochondria shells, diploid shells? Indeed, if it's similar to what's happening in this yolk, it is actually in this membrane. It is the front guard. If it's similar to what's going on in the yolk, because that's what these scientists found. And I will get to this paper in a moment. It is so exciting. And what they also found was that copper so you've got the egg, and this is where the manganese makes the egg shell nice and thick and strong. That's what it does. That's where they found it. You take away that manganese, you get eggs that break. We remember those eggs if we're old enough. Eggs didn't used to be, eggs do not break anymore to buy from the store. We don't eat the shells though, do we? So we're not getting that manganese. But they use manganese to make those shells strong and thick. And I told you, manganese creates material. So you take away that manganese, you have a thin, breakable eggshell. Great. Science, beautiful plants, wonderfully complex, informative origins of life, science. And it's not too hard to understand. It's not too hard to sleep on this information and continue this science as we fight and recover from COVID-19. We fight and say, wait a minute, we don't want you as our next mitochondria. We made some mistakes, we're going to fix them. And we're going to start with bringing this planet back, giving it a breather from carbon dioxide. Check. We're going to start by understanding the power of oxygen in our own systems and committing to wearing an oximeter, understanding the power of an oxygenated subconscious brain. I'll talk about that in my next Pro-Oxic this morning. Oh, wow, such good science, such good science. And etc. So let's look at this. I mean, I just don't want to get on too much of a soapbox, but it's an empirically based founded soapbox. I am not making this stuff up. I am doing it to help stop this pandemic and so that we can recover. Another thing, the methane we eat all the time. We need to regroup. We need to reprocess and rethink what's in our drinking water, how often. So I've been taking manganese. I have plenty of it in my system. I have been gaining weight. I don't need to eat as much. So we need to rethink. If we're going to survive this and continue to evolve, evolve beautifully, perfectly with our wonderful mitochondrial hosts who are being destroyed with this virus, whether we die or not, the mitochondria are going down when this virus comes in. That's just the way it's designed. Okay, so dealing with the methane, maybe rethinking our food supply and giving farmers something else to grow, etc. Because methane is the next issue we need to, and other issues. We know there are issues out there. If we don't acknowledge that, then we're in the dark. Let's look at this article. Awesome. Eggshell matrix proteins, avian eggshell mineralization, effects of manganese content in laying hen feed with a different on eggshell quality and bone mineralization, stabilization. They go into calcite and lithium a little bit. Lithium stops the process. This salt messes it up. Influence. I'm just popping at the references a little bit. Okay, so what did we find? And I took some specific notes on this as well. So such interesting information. Manganese activates glycosol transferases in the formations of mucopolysaccharides, which are compounds of proteoglycans, glycoprotein, protoglycans, right? In bone, they enable it to resist compressive charges. So this proteoglycans, the virus is a glycoprotein. So it's just a matter of balance there. Doesn't surprise me, it's opposite. Zinc and copper and manganese dietary supplementation did not affect the percentage of the amount of the acreage of the eggshell, the shell weight per unit surface area, or the stiffness of the egg. There was a elastic modulus, which is how you can pull an egg and it not break. We don't want that yolk to fall, explode either. Consistently, we observed improved breaking strength and fracture toughness, resistance to fracture in the two oldest groups at 1, 5, and 9 week. The experimental diets, and they gave natural manganese and they gave artificial manganese. Same. Manganese creates stuff. And that's why it's filtered from our water, because it clogs up, it creates filament and stops pipes. Look at Alzheimer's, tau production, dehydration after hypoxia, after A beta from hypoxia, A beta 42 from hypoxia, tau from dehydration. And that creates tangles, I believe. And there it is. This is, more causal support for that. Manganese deficient diets produced eggs with thinner shells, translucent areas in the shells, abnormalities in the eggshell ultrastructure, particularly in the mammillary layer. I'm not sure which one that is. I have to look that up. So it causes that, when you don't have manganese, the mitochondria get misshapen. They get weird. They're vulnerable. Copper deficiency in the hens also resulted in abnormal eggshell formation. So abnormal distribution of the shell membrane fibers, egg shape deformation. So that's what copper goes on the heels of calcium to protect the integrity of a new cell and function. And without copper, the shell gets misshapen. And if it's running loose in the system, it's going to cause blood clots, which I would say are misshapen blood. Zinc is crucial for supplying carbonate ions during eggshell formation. Inhibition of zinc greatly reduces the weight of the eggshell. So this is all origins of life information. We have to look at it that way. And I can go into many tangents from what I just read there, because zinc and copper on carbon produces the embryogenesis activations that differentiate the DNA. And here we have zinc, I'm sorry, where'd it go? Zinc, this carbonic anhydrase enzyme. Hydro is hydrox is to take it away. Hydrase is to add it without adding the oxygen. Just like without adding the oxygen. Zinc. I tell you, it's science, you got to review this stuff. Inhibition of zinc reduces the eggshell weight. Inhibition of no zinc in here, and when there's no oxygen, you're going to have a low weight premature infant. Concentrations of manganese and zinc were generally, manganese and copper were higher in the eggshell samples than in the yolk samples. But levels in the eggshells did not increase with a corresponding increase. In other words, you give a lot of manganese and zinc here, you're going to get it in this shell, but you're not going to get it in here because this shell is not letting that in. This is very selective, creating the yolk. And an egg yolk, eggs and an egg yolk is very similar to a human and try-1 embryogenesis. Isn't it now? It's glorious. I couldn't believe, so I was ready to slave away digging into farming supplements and fertilizations, but I got perfectly held over with these egg studies. Unbelievable. Eggshells did not increase. Levels in the eggshells did not increase with the diet or in the yolks. The concentrations of manganese and copper, again, remember copper gets higher here. Zinc is high and copper is on the tails of the zinc. Then copper gets a higher load and the zinc gets a lower load while the fertilized egg is differentiating. And let's put that 1 trillion down here. In about 16 weeks. Then both of them, zinc goes into zinc storages and comes out to kill stuff. And copper continues on to protect on the heels of calcium to protect integrity of a cell signal. But copper and manganese line up as it protects the evolving, the differentiating fertilized egg. All right. Let's keep going because these are really interesting findings. Levels in zinc in comparison were much lower. Levels of zinc in the eggshells were much lower than in the yolk and decreased when hens were fed higher levels of zinc. So the levels of zinc didn't get into that eggshell. As we see, zinc goes down and then gets stored for emergencies. Withdrawal of zinc, iron, and copper for 10 week has no effect on egg production or egg weight. For 10 week, I don't know if that's a 10 week. 10 week, you see they did it on younger and older. So younger hens have different absorption rates of these minerals as we do. Like I said the other day, once we hit 30, once that brain is finished, all that matters is what we do. So we come out of this try-1 where we have zinc and copper and zinc, switch over 0 to 16 weeks. Once we come out of that, it's like once we come out of the eggshell, this shell, we have a shell-like membrane, nothing's getting in there. And if it does, we're very compromised. Once it gets in these levels, zinc gets stored away, and we gradually become more and more oxygenated as the brain cleaves. We go from 1 trillion to 100 billion, and that is a process of killing off what works, what we need, what kind of parents we have, how we form through the course of our lifespan, which is another thing that needs to go on the table exactly because of this information. So once we reach 30, all that matters is what we do on the next breath, because oxygen sustains these 100 billion, right? And that means cooling concussions and use of music as free energy, many other things. Aging brain health. Removing manganese from the diet reduced eggshell weight in hen laying eggs, who characteristically have heavier shells. Diets not supplemented decreased egg weight in old hens, but not in young hens. Does that make sense? So you take away these things, zinc, manganese, and copper in older people, and you're going to get problems. But here, they're still pretty well working away because they are the ones that cleave and cut. So in young hens, there's no problem. There's plenty of that already going on. You can take it out of the diet, but they've still got plenty of it anyway. Whereas with older, taking those things out of the diet messes up the egg. Here it doesn't. It's got a good egg. You take it out, if you take these things out here, the egg's still good. If you take it out when they're older, it's still bad, because they play into the integrity of the egg. All right. The addition of these things to the diet in the study did not influence egg weight in these young hens, because they already have all this stuff. Egg weight was significantly, in contrast, was significantly lower in both groups of older hens receiving trace element supplementation to the basal diet. I don't quite understand that. Okay. In the oldest group, supplementation in the oldest hen group, giving these things resulted in an immediate decrease in egg weight, whereas in the other older group, 60 to 73 week, the decrease only became significant after the 9th week. Gestation. Elevated zinc did not affect shell thickness. Okay. Shell thickness is impaired if copper levels are way up. Oh, let's see. And they talked about elasticity. Improvement in eggshell breaking strength when supplied with manganese. All right, and the more manganese is stronger. Trace element supplementation, early fusion, etc. Manganese absorption and retention by young women is associated with serum ferritin concentration. Another thing is what we're looking at with the, okay, so this is, there's a lot of science that we need that's been done on these elements that we need to, just pair up with how we evolved. We have it's the difference between a chicken and a human, of course, but there are a lot of similarities that I saw in these many papers, because Lord knows we have eggs that don't break anymore. At least at Trader Joe's, I know that much. And the science behind that is manganese. But we don't eat the shell. So that's where the manganese seems to go. We need to get it in our system so that it works with our mitochondria to bolster them. Anemia, deficit of dietary iron, increased manganese absorption. That makes sense. So anemia is low iron, right? And increased manganese absorption, because we're only going to bring in as much as we need. That's the idea of these papers too. Okay, and so that makes sense. So when a mitochondria, there's anemia, low iron also means low oxygen, because iron binds with oxygen to deliver it, but that's not happening. When that doesn't happen, the mitochondria shoot out manganese to split oxygen from water so that they can salvage that way and continue to function. But it eventually knocks them down. You get rid of all the manganese, and like the eggshell, the thing gets weak and breaks, and you can enter and transparent. And in the case of COVID-19, I guess it's still doing electron transport to, at this point. But in the case of COVID-19, the virus has moved in and sucking things up and taking things apart, taking the mitochondrial RNA, and the electrons are not being exchanged. So they're building up, which makes me think that, when manganese 2 goes to manganese 3, materials are generated, which makes me think that these extra electrons are serving the virus. All right. So when it's anemia, when the iron is low, the manganese bumps up its absorption. Iron, they're saying maybe iron and manganese share a common cellular transport system. I don't know about that. But excess of one element inhibits transport of the other. Individuals with low ferritin, now that's what we're looking at. All this, so manganese is out of the way. Oh boy. And we usually, in COVID-19, ferritin is a problem, right? Right? Isn't it fun? This is great science. It's so intense. So in COVID-19, we are looking at 10,000, 20,000 ferritin units. Now, what's it supposed to be? Healthy? 0 to 400. Wow. So what this is saying to us, what's it saying to me? That when you have high ferritin, oh gosh, let's go. Low ferritin absorbed more manganese in individuals with high ferritin. So this high ferritin is moving in because iron is all over the place because there's no oxygen anymore, right? So when you lose your oxygen supply, iron goes loose. Ferritin goes to pick up the excess iron that we have because it's not being employed. And of course, COVID targets that heme. All right. So when we have low, when we don't need to be mopping up all this iron, manganese is increased. I think that's what it says. Now that's to me in an initial look, that's counterintuitive. Manganese was 5 to 10-fold greater for the low manganese diet than for the high manganese diet. When the retention of dietary manganese individuals with low ferritin absorbed 3 to 5 times more manganese than individuals with high ferritin. I guess that's why they think it shares the same transport. So if they've got low, you get a lot of manganese. All right. That, to me, that's healthy. So you have, when there's low ferritin, your iron is paired with oxygen to be pro-oxic. And when there's low ferritin, if they share the transport, okay, I'm going to read those papers because that, if that's the case, equals more manganese, not for survival necessarily, not for survival of the cell, but for protecting it, protecting the integrity of healthy mitochondria. And so you're not getting COVID when you have healthy mitochondria. And manganese are inside mitochondria. So too much salt. Oh, that's your salt supply. You got tanks of it. You've got tanks of salt, and you spoil that COVID broth. You spoil it. A little more here, and I will, wow, it's a 50-minute lecture. Okay, folks. When the retention of dietary manganese was estimated, subjects consuming the diet high in manganese retained less than twice as much manganese as subjects consuming the low diet. Manganese retained for low and high serum ferritin, respectively. Woof. High ferritin, low manganese uptake. I'm sorry. Yeah, and low ferritin, high manganese uptake. But you can have, it will take up as much as it needs. depending on the situation. Well, thank you so much. This was a very intense lecture, but powerful and meaningful. And I hope these things are starting to add up in your head, and that we can look at manganese as an effective triage. So with these high ferritin levels, manganese may not even be absorbed. So maybe we need to have it intravenous or in a vaccine, because manganese too much will spoil that COVID broth, will disable that lock. We talked about in the last 2 sessions. Please contact me if you can think through this with me and work with me on this. Thank you. And have a great day. Let's go pro-oxy in a minute. Let's go for our pro-oxy.